For today, I want to actually continue where I left off yesterday, which is where we were building the example application to create an Excel add-in with our GraphQL data. So let me go to the repository that I'm working with. I uploaded it in here, so all the code that I'm working on is in this repository. Let me just also push that onto onto here so that you can follow what I'm doing, and I can also open it up in Visual Studio. So let me do that. So yesterday I was a bit struggling with this Excel plugin because I wasn't able to create a why am I looking at this? I wasn't able to create a old style project so that I could start using Excel DNA with. And just a little recap, if we go to Excel DNA, it is the tool that allows us to build custom Excel functions using .NET. In this case, we will be using F# to get our data for data access, to build the data access tool as an Excel add-in to get the data from GraphQL and push that into an Excel sheet directly. So this is the tool as well. Let me add it to the chat. You can check it out, which is the one I'm using in my repository. So this is the project. Not now. This is the project. I have my console app, which we've seen before. Just generate an Excel file. This is the simplest version of using the GraphQL data. We create an instance of the client, and we get the data. From the data, we make an Excel file, and we write that out to our file system. That's not very impressive. It's pretty simple, but sometimes you do need to create Excel files easily, so we're using that to create them. But today we will do something different, which is to create an Excel plugin that runs inside of Excel. And the project I have in front of me is the one I tried to create yesterday, but I wasn't able to. I had a couple of missing things here and there, but after I managed to get a working project, I added it here, pushed it to GitHub so that you could also use it. And if you want to start from scratch to create your own Excel add-in, I created another project, another template. Let me show you another project, which is a public template. This template includes a bare bones Excel add-in which you can add to your solution, but you have to basically copy this project. It's pretty straightforward, and it has one hello world function. I will show you how it works in a bit, and some table and cell abstractions to easily create 2D tables. I'll show you in a bit how that works, because this is pretty nice. All right, so with that, if you want to keep up with the project that I'm working on, and you didn't have the Excel plugin project, you could simply get it from here from this template and add it to your solution. You will need Visual Studio to run this application. We cannot use Ionite for it, but that's okay. So from Visual Studio, if you set it as your startup project, which I have already here, and you run it, it will compile the application, make the Excel add-in, and expose the functionality in an Excel session. So that's pretty cool. The way that Excel DNA exposes these functions is by taking the static functions, and if it sees that the types are compatible with Excel. For example, this is pretty much a really simple function that takes a string as input and returns a string as output, which will in turn create one cell in Excel. So this is a function that will be exposed. It's called hello, it takes name and returns a string. In this case, you're just gonna use sprintf. So just to show you how that works, we will start it off. Of course, if there's anything wrong, the sound or the lighting, for some reason, I just forgot yesterday to turn on the lights and forgot to turn on the music. So I'm not gonna publish that stream of yesterday to YouTube. I think if everything works here like it should, I will publish this one to YouTube. So, okay, so we built the application. We're starting it now in debug mode, and it opens up my local Excel instance, and I should tell it to enable this add-in only for this session. So now it has been loaded in, and I can start using it in my Excel files. So if I start from scratch, I will be like, okay, world, that will be our data. And here I go equals hello, and there we go. That's the function that was in the code. So if I tap into it and choose the A1 cell to be my input, it will run hello world. And this formula is of course reactive because we are inside of Excel. So if I change this to Z, it will every cell that depends on it will also recompute. So this is pretty cool. I thought it is really nice. The only limitation that I still don't like about this Excel DNA tool is that it doesn't work with new SDK style projects. I think they're working on it, and I might also look into it, see how we could make it work with .NET style SDK style projects, because it's really, really nice. It's really easy to get data into Excel, especially if your team or your company works a lot with Excel. That's kind of what we're doing here. So with that, let's talk about what you can do with it. So creating a single cell is kind of nice, but that's not a lot of data. So here you could return a string, an integer, decimal, date, time, these kind of things. So that's cool. But you could also return a table, and a table is, okay, let me stop that, don't save, stop it here. And a table is basically a 2D array. So static member, let's create a table. Let's create a matrix, which takes a number n, and it will create a n by n matrix. So that's an array 2D, which is this function. Notice that it's a two-dimensional array. It's not per se an array of an array. It has to be a two-dimensional array. So this one will take 2 sequences. I guess that's good. So for I in 1 to n, 1 to n. Can you do that? So from 1 to n, 1 to n. Is there an easier way to do it? I don't know. I guess this one's the easiest. So basically this one returns so matrix now returns an integer matrix, which I guess is fine. So let's see what this generates. To be honest, I'm not sure if this will work. Let's see. Let's start it off. Of course, if you have questions or anything, you could just let me know here. Yeah, I'll check out the chat every now and then. All right, enable this plugin. Let's make a new sheet, and let's say I want 5. And here I'll say matrix. Okay, it wasn't loaded apparently. Matrix. Okay, it's not known here. I think I know why. Let's see if the other one is loaded. Yeah, hello is still here. Does it take an integer as input? That would be funny. Okay, so Excel DNA is doing some kind of conversion, I guess, because this is a number here and hello expects a string. Okay, that's kind of cool. So our matrix function was not exposed, and I believe that's because the 2D array has to be 2D array of objects. So the output should be boxed. Okay, it's still okay. Yeah, I can't do this. For I in 1 do for j in 1 to n do box n. I mean box j. No, that still generates one. I feel like this is not correct. I should be using the I somewhere. Is it I times j? I'm not sure. It is I times j. Okay, so now it returns an object to the array. Well, I could also just do box n, and that would be the same number all over the place. But let's do I times j and box that to create an object from it. Okay, let's go ahead and try that. Okay, blank. Let's see if it was registered. Matrix, there you go, it was registered. So when Excel DNA detects that the types are correct, it will register them. So let's go with 10 or just 5, I guess. And here we'll say matrix. Oh, I also always do the enter, but I mean tab. So matrix of A1, and that will create a nice table from the data. Okay, I'm not sure why I did I times j. I guess that's just an example to create a nice multiplication table. 2 times 2 is 4, 2 times 3 is 6, etc., etc. So that's like really, really easy. So the magic is in this 2D array function, but that's not always straightforward to create, and it's a bit dynamic, so things can get hairy here. So what I did is I created some abstractions for this. Some abstractions with the cell type and a table type. Don't worry about it too much. Let's look at how to use them. So here you can create a matrix, and of course the shape of that matrix is dependent on its input. So if I say 10, go all the way to 10. If I say 3, it will go 3. So that's really, really cool. The reactivity of Excel just propagates here. It's really nice. Okay, so we want now to get some good data from here. We want to get some good data. I was hoping there was a better way to debug this thing, because I don't like stopping the application, going back to Excel and rewriting everything. But that's all right. Let's do that. Don't save, stop. And let's work with some data. Let's see which data we have. Well, we do have the company data, which is great. So what I will do is let me add a reference to the company data. That's great. So now, by the way, the company data project, if you remember, is the project generated by Snowflake. and it's a net standard 2.0, so it can be referenced from this Excel plugin project because it's targeting 4.7.2. So that works okay. However, there's a little bit of a gotcha here, because if we build a project, we'll build just fine, I think. It will build. It says it build succeeded. It built both projects. However, if I go to the bin object debug, okay, company data was here because it's the reference. It's a reference project, but we have a little problem because company data uses Fable remoting and some other dependencies which are not in the output folder, which are not here. And to use them in Excel, you have to have all the dependencies in here. So what we do is the following. Let me open this up in Visual Studio Code. And because I can see more files than here. Well, I guess I could add the Snowflake dependencies here. Existing item. I want, well, the README, Snowflake, the Faker GraphQL schema, maybe those two, git ignore, what else? Yeah, basically everything, right? Okay, these are the solution items. And I need to regenerate company data such that it knows to also output the dependencies in the output folder. And there's a specific option for that. Let's go to Snowflake. There's one here. It's called copy log file assemblies. Copy log file assemblies, and this one should be true. It's false by default. And if we look at the docs, it says add the attribute to the generated F# project for scenarios where embedding the dependencies is required, which is exactly this scenario that we're talking about. So after I change the Snowflake configuration, I need to run Snowflake to get a new project. I will need 2 PowerShell scripts because one will be for running the fake backend. So npm start to run the fake GraphQL backend, which will run a server in the background. We'll wait for that to start up. Okay, it's running. And in this one, it's running here. We have the queries. All companies. Yep, still working right like it should. That's great. Yeah, here we can say Snowflake. Let's run it. Make sure everything still works. Yes. So everything works. We will generate. Okay, it generated the project. And now if I take another look, this attribute was added to the generated project, which is great because that means if I build the Excel plugin project, I should get all my dependencies in there. So let's rebuild. All right, 2 projects succeeded. And now if I look here, I should see that indeed Newtonsoft JSON is included, remoting JSON is included, and the company data is included. And now I can start actually using the generated GraphQL client from our Excel plugin. So to do that, well, I can't just have loose values here. So I will just say util or something like that. And auto open this one. Please don't do this, but it's just here for demonstration purposes. So we want a client, an HTTP client. Well, we don't actually need one, but I guess it's better to reuse the same client. Let's see, what did we do here? Yeah, here we just use it like this. Okay, we can do that, I guess. I need to open company data. Yes, there you go. Now I have the client and I can use it here. So far so good. So let's create a nice function for the companies, and here I will start using the table API, show you how to use that. It's very similar to the Excel API that I'm using here, except that it's not as configurable as this one, because here we can say adjust to contents, change the colors and stuff like that. But here I could only return primitive values. So with that, let's start writing some. Let's say companies. It's a function that does not require any input. And what it will do is it will call the client. So match client, get all companies. I want the non-async version. I don't care about async here. With. So if I get okay of response, I do something. Otherwise, if I get error, some server errors, I'll do something else. If I get server errors, I'll just return a string. Well, I could just return a table which has a scalar value, and that means it's just a single cell. And an error occurred while retrieving the data, the company's data. Okay, so this one returns a table with one, like also an object to the array with one value. But here in response, we can say let companies, exactly the same way we did here in the console app. Let companies is response.allCompanies, like this, which is a company list. And from this, I could create a table. So table from companies and a list of mappers, basically. So these mappers will tell me, or will tell the table API how to create each cell. And you can do that easily from companies cell, and then from each company we will go company.id, copy paste this a bunch of times. We want the ID, the name of the company, and the industry, I guess. Industry. So cell here is an overloaded function which can take a lot of primitive values and convert them to Excel cells. So this is pretty much the code. It's not a lot. And here we create a table from the companies and tell how each field should be created. Okay, let's see how this looks like. Let's hope it works. Okay, it's building it, everything. About to call Excel, enable this for this session. And let's try it out. Companies. Hey, companies. So the function was registered, that's great. I will say enter, no. It's companies, and then just call the function. Woohoo! That actually worked. That's awesome. So no problems with loading assemblies, no problems with actually No problems actually executing the code, serializing the data, deserializing the data. Everything's working. That's awesome. And now we get our companies thing. I think I can also rerun it. I mean, every time you rerun the query, it gets the new data. Yeah, it gets refreshed every time. So that's great. Yeah, it is nice, huh? So we go back to our code. What we're missing here is headers. So let's add a couple of headers. Let me see if I had the extensions here. Yeah, I did have an extension here, so we could do ID. ID goes to this table cell. Name goes to this table cell. And finally, industry goes to this table cell. All right, let's give that a try. Stop, go back again. Okay, enable. So we will go equals companies, run. And there we have it. Headers for each cell. That wasn't too bad, huh? All right. Okay, I think every time something happens, it reruns the code, it reruns the function. But the GraphQL faker will just keep creating new data, which I don't mind. This is good. This is nice. Yeah, this is what I wanted to show yesterday, but I wasn't able to. But now everything's going nice and smooth. And you could also do this. You could also do this if you're following along with Snowflake, with the Excel DNA plugin and everything. This is still working, and yeah, you see the same thing here. All companies, and then every time you run the query, you get new data. I guess you could configure the faker to return the same data each session, but that's all right. All right, let's see what happens if there's an error, because here we have an interesting thing. So when working with Snowflake, every query will return a result of either the return data or an error type. And the error type is a simple message of string. The problem is that this error type is not part of the GraphQL schema. It kind of, the GraphQL services decide how the error type looks like. So this is a bit of a problem. Let's look at how an error looks like. So if we say industry like this, we should get an error back from the server. Okay. So a single error does have a message. A single error does have a message. So in this case, our error type will be correctly deserialized. That's okay. But if it wasn't message, say it was message, if that's the result returned, you could also customize that with Snowflake. There's an error type config thing here, which allows you to customize the error type returned to more complex shapes. I guess I have an example for this. Yeah, here for example, the custom error type is something that has a message which is of type string or path or request ID. But in this case, the defaults will just work. So with that in mind, let's actually use these errors. So instead of saying an error occurred, let me close that. Instead of saying an error occurred, we'll actually render those errors as a table. So here we say table from server errors, and then server errors dot cell on error goes error message. There you go. That isn't too bad. We could also do this. Okay, and now just to make it fail by manually changing the code, manually working with the client. You're not supposed to do this, of course, but we just want to get an error somehow. So get all companies is gonna execute with a wrong query. So let's see how that turns out. All right, so back at it again. Companies. I was keep pressing enter for some reason. Companies and go. And there you go. It shows the error message now instead of the data. Cannot query field industry DDD on type company. Did you mean industry? Which is exactly the message that was returned from the GraphQL thing here. So now it should work. All right, that's cool. We have error handling, and so in both cases, when things go well, we render the data. If things aren't going well, we also render some kind of data. Of course, if you want to go even further, you could put this around a try catch and then render a table from the exceptions, even though that wouldn't be as helpful for the users. It will be helpful for people who are debugging it, of course. All right. And another nice thing is that you could actually put breakpoints here, and it will break. It will break from hello. Okay. And it will break when you use the function. So if I'm inside of Excel, because I'm in debug mode, I just clicked on it and it runs the function again. So now I could actually see and debug my data from Visual Studio. That's not bad, eh? Continue. Don't care about this. Don't save. Okay. So yeah, this is pretty straightforward, pretty easy to create those things, which is not bad at all. I think there's a function here called from that I need to delete because that wasn't... I need to delete this because this wasn't type safe. No, this one is type safe. I think create was not type safe. Yeah, this one wasn't. Okay, let me remove that so that we don't... Yeah, the from function is type safe. All right, so this one works. Let's make another one just for the sake of testing. And this time let's make it take some input to search through the employees. So let's go static member, search employees, I guess, and using some kind of query, which is a string. Let's go client match client dot... Well, I have company by employee ID, company by employee ID async, all companies. I guess I'll just use all companies again and then get all the employees from each company with okay response. I guess for the errors, I'll just do that. So let all employees will be response dot all companies, which happens to be a list of companies. So we will list concat No, we will list map each company to its employees. Well, I guess map concat is collect, right? Company employees. There you go. Now we have the data, which is an employee list. We will also filter employee where the employee name should filter by last name. Let first name is default arg employee dot first name, like this, or is it the other way around? Yeah, it's like that. Let last name equals default arg employee last name, and then it's either first name that contains the query or the last name that contains the query. I'm pretty sure there are better ways to do this, but for now this is fine because we're able to get the data, do some manipulation or transformation, and then show that into Excel. So table from employees, and again it's just the same old API. Employees.cell on employee goes to employee dot first name last name. What else? Status. I guess status is the type that I added myself. Okay, let's also do the ID. Why not? Address to address, and finally do the status as well. Except that status is something that the cell function doesn't know about, so I guess we could just toString that. This is the union that I've added. So you could either make a helper function that formats this the way you want, or just keep it as is and then toString will do the rest. Alright, so yeah, this one was pretty straightforward, I guess, as well. Okay, let's see how it works. Oh, yeah, that's not gonna work because I did not revert to the change I made to... I should revert the change I made to this one, right? Well, I don't need to revert, I could just rerun Snowflake again. There you go. Hey, that's nice. Okay, and now I could rebuild, and now I could run it. Oh, sorry, I was muted for a second. Thanks. Oof. Yeah, yeah, the microphone, yeah, of course. Sorry, my bad. I was just saying that this is pretty much it for the example. This is what I want to show in the next F# exchange. And yeah, I could also add more headers here, but you get the idea. I just did that in here. Both functions are working, so that's no problem. Yeah, so like I said, 2 ways to use Snowflake for now, using it in a console app, in an Excel plugin, and next up will be showing how to use Snowflake in Fable. So if you change the target to Fable, you'll be allowed to, the generated project will change its dependencies, will change its files to become Fable compatible, basically. The reason I actually started working on Snowflake targeting Fable initially, and then I added more features as time went by to also support F# projects like on .NET, and that's been working really good. So that's nice. So yeah, I'll try to see if I could get a Fable project for the next stream and see how that goes. So the reason I started working on Snowflake and writing it was because the existing type provider, there is a type provider for GraphQL queries. I think it's F# GraphQL, F# data GraphQL, which actually has a type provider. Let's see. Yeah, it has like a, okay, this is the queries and there's an engine here. Let's see if I could executing on the client side, GraphQL on the client side. This is what I wanted to use at first, but the GraphQL type provider wasn't supporting Fable, and because it generates, and because of the limitations of type providers, for example, only generating classes, it wasn't very suitable for Fable, because the reflection support for Fable only works on F# records, F# unions, and these type of things, which is also what the serialization libraries depend upon. So on the Fable side of things, I use Fable Simple JSON, which also expecting the types and data to be records and unions and not classes. So the reason I started working on it was because the provider wasn't compatible. I also, like, to be fair, I started working on this, like gave it a shot to make it Fable compatible, but it was just so much work. And even the maintainer of, I even talked to the maintainer of this project. I think his name was John. And he very generously said that he will help me out if I need any help, but the code of the provider was just too much. So I started from scratch and wrote Snowflake to be a code generation solution instead of a type provider. So you get all the benefits of the code generation without the limitations of a type provider. There is, of course, a couple of things that needs to be worked on the Snowflake side of things. For example, there's now a feature being worked on to add compile time generation. So here we generate the project by hand, but it's also nice to have an option to say, okay, every time I build a project, I want this thing to be regenerated. I want the project to be regenerated. Even though I believe you could just do that here or have it as part of your build script. But I guess like there are different scenarios that can be supported for this solution. So with that, I think I will wrap it up for today. I'll be pushing the code to GitHub so that you can see it. I'll be pushing the code still to my repository, the one with the F# exchange. And you could get the code here and actually run these things on your own. Well, to run these things, you have to remember you have to actually run the GraphQL backend here, and then generate the file, and then use the Excel plugin. So with that, cool F#, thank you. So with that, thanks a lot for watching, and hope to see you next time. where we'll try to go into the Fable land and see all the gachas in there.